This is another video in my series on alternating current. In this video, I'm going to work on an alternating current circuit example using real numbers. You will find this topic, along with others, in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stan Store at this web address. Okay, let's try and cement some of that theory with an example. Let's put some real numbers and into a series RL circuit and just see how it works. In our circuit here, the resistor is 5 ohms and the inductor is 10 millihenries, and the frequency that we're working with is a standard North American frequency of 60 hertz or 60 cycles per second. In this example, XL is given by 2 pi times the frequency times the inductance, which is 2 times 3.14159 times the frequency, which is 60, times 10 millihenries, and 10 millihenries is 10 over 1,000 henries. So we multiply those out and end up with a reactance for our inductor of 3.7699 ohms. Therefore, the impedance, the total impedance of RL in series is the 5 ohm resistance added to 3.7619 ohms inductive reactance. Now remember, these are both phasors, so they have to be treated as phasors. So they are, the resistance is 5 ohms along the real axis, which is at 0 degrees, so it's 5 at 0 degrees. The reactance is 90 degrees, so it is 3.7699 at 90 degrees. And we want to add these two together, so we're going to convert them to a rectangular notation, which is 5 plus J 0 ohms plus 0 plus J 3.7699 ohms, which when added together will give us 5 plus J 3.7699, and if you want to convert that to a polar notation, it's a magnitude of 6.262 ohms at 37.016 degrees. As with the purely inductive circuit, the current wave lags behind the voltage wave of the source, although this time the lag is not as great, only 37.016 degrees as opposed to a full 90 degrees, as was the case in the purely inductive circuit. In this case, the current is modified by the fact that we put a resistor in series with the reactance or the inductor, and that has a tendency to straighten out the lag. For the resistor and the inductor individually and their voltages, the phase relationship between the voltage and current hasn't changed. Voltage across the resistor is in phase, 0 degrees phase shift with the current through it, and the voltage across the inductor is still 90 degrees out of phase with the current going through it. This video is part of my electrical training information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I'll also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned products, and it also is a connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need in the future. Also, by providing me with your name and address, I'll be able to forward you information to connect you with electrical products and to provide you with notifications of more electrical training videos. This address, of course, is case sensitive. I will spell it out and make sure that you have it right. https:// bit.ly/3 uppercase U uppercase G lowercase j uppercase B uppercase I and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂's products and obtain a free copy of my three-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products.